In this video, we're going to look at how to solve an equation with its graph. So the first example we have is the graph of the line y equals 1/2 x minus 4. So let's say we were asked to solve the equation -1 equals 1/2 x minus 4. Now, some of you might know some ways to do this algebraically by doing stuff to both sides and isolating the variable and all that good stuff. But it's a good practice to think about things in different ways. So we want to look at solving equations with graphs, solving equations with tables, and solving equations algebraically as well. So notice that this equation mirrors the graph of the equation, except for the fact that we see instead of y, we have -1. So what we've really done here with this blue equation that we're solving for x is we've replaced y with -1. So in order to solve this equation with the graph, what we want to do is we want to go here and we want to find on the graph where does y equal -1. So remember, you've got your y-axis here, your x-axis here. So y is -1 right here along this line. So we're looking for a point on this line where y is -1. So what I can do is I can draw a horizontal line through -1. All these points, got a little bit off track there, up on this line. Whoa, okay, there we go. All the points on this green line have a y value of -1. So if I see where that line intersects with the red line, which is at the point 6, -1, this tells me when x is 6, y is -1. So the solution to this equation is x equals 6. And we could check that. Let's do that. Let's check. So if I put 6 in for x, does the result on the right-hand side equal -1? Yes, it does. Check. All right, so that is the solution. Let's try another one with this same graph. All right, so now I change the equation to 3 equals 1/2 x minus 4. Can you use the graph of the line y equals 1/2 x minus 4 to solve this equation? Why don't you pause the video and see if you can figure that out, and then unpause the video when you have it. All right, so in this case, the y value is 3, so I drew a horizontal line through 3. And now I want to see where does this horizontal line intersect with the red line, and I want to notice the coordinates of this point. So the point over 14 up 3 is a solution to this equation, which means that when x is 14, y should be 3. Let's check it out. Half of 14 is 7. Take away 4 is 3. That works. So the solution to this equation is 14. All right, well, we can use this strategy to solve much more complicated equations, not just linear equations. So let's take a look at an example of one of those. So here we have the graph of y equals x squared plus 2x minus 4. And this actually makes a graph called a parabola. Now, you may not have experience with these kind of graphs, and that's okay. We just know that every point on this parabola is a solution to this equation. All right, so for example, let's find a nice point right here. This point, x is 1, y is -1. So if I put 1 in for these x's, and I should get -1 for my y. I should get -1. Let's try it real quick. All right, so if I put 1 in for these x's, I get 1 squared plus 2 times 1 minus 4. So what would that give me? 1 squared is 1, plus 2 minus 4. 1 plus 2 is 3. Take away 4 is -1. All right, and so every single point on this parabola will make that equation true. So let's say I want to solve the equation negative 4 equals x squared plus 2x minus 4. Now, you may not know how to do this one algebraically. You may not have learned this yet. So this is where solving it graphically, you have the advantage of being able to find a solution in a different way. All right, so I'm going to write the equation underneath here. So notice the equation of the graph. So notice what we have is we have a negative 4 where the y is. So what we want to do is we want to look on the graph and find all the places where y is negative 4. So that would be any place along this line. And we can see that our graph intersects in two places where y is negative 4. So on the graph, we have the point negative 2, negative 4. And we also have the point 0, negative 4. So what that means is when x is negative 2, y will come out to be negative 4. So that means that x equal negative 2 is a solution to this equation. And unlike the last example we looked at, we have two solutions here. If x is 0, y will also come out to be negative 4. So that means that x equals 0 is also a solution. This has two different solutions. And you can write your solutions in what's called a solution set with these set brackets. The order doesn't matter. This is not an ordered pair. This is a listing of values that are solutions to the equation. If there were three solutions, you could list all three solutions. Generally, we list them in order from least to greatest, but technically those two ways of writing it would both be correct. All right, we could also use this graph to estimate. You may have noticed I picked a nice one that came out nice, but let's say I wanted to solve, let's pick something that's not nice. How about 2 equals, when I say not nice, I mean not a whole number. We're going to have to estimate. 2 equals x squared plus 2x minus 4. So now my y value is 2. So I'll look on my graph over here at 2. And now I see, again, my graph intersects in two places, here and here. So what are the coordinates of those points? Well, we know y is 2 because it's up 2. But what is the x value? Well, this is where we're going to estimate. I can see it's between 1 and 2. It looks like a little more than 1.5. I'm going to guess maybe 1.6. And over here, it looks like maybe negative 3.6 up to. So I'm going to say my solutions are approximately negative 3.6 and 1.6. And I can guarantee that they are not exactly that number, but using the graph gives us a good way to approximate the solutions as well.